Welcome to The Explainer. Today, we are diving into the incredible team that works 24/7 inside every single one of us, our blood. And look, it is so much more than just a red liquid. It's this complex, amazing crew of couriers, soldiers, and repair specialists, all on a nonstop mission to keep you alive and kicking. So let's start with a big question. What is this river of life exactly? I mean, it makes up about 8% of your total body weight, but what's actually in it? What's it made of? Well, if you break it down, your blood is really a mix of two main things. About 55% of it is this yellowish, protein-rich liquid called plasma. And the other 45%, that's what we call the cellular elements. You've got your red cells, white cells, and platelets, all just floating around in that plasma, each with a super important job to do. So here's what we're going to cover in this explainer. First, we'll look at the workplace where blood does its thing. Then we'll meet the key players, the oxygen delivery crew, the defense and repair team, and finally, we'll get into how blood acts as our own personal and very critical ID. Okay, so first up, the workplace. Your blood operates within the circulatory system. You can just picture this massive, intricate network of highways and side streets that connects every single part of your body. And the blood itself? Well, that's all the traffic, constantly moving, carrying vital cargo to every last destination. Its core mission really is transport. Think of it as the ultimate logistics company. It's delivering the essentials, like oxygen from your lungs and nutrients from your food. And on the return trip, it's hauling away all the waste products, like carbon dioxide. But it doesn't stop there. It's also in charge of regulating your body temperature and delivering important messages through hormones. It's a busy, busy system. So, who's actually handling all these deliveries? Well, the most numerous members of the team by a long shot are the red blood cells, also known as erythrocytes. Their one mission, which is absolutely critical, is to run the oxygen express.
And when I say numerous, the scale it's just hard to wrap your head around. Get this, that number, 5.4 million, is how many red blood cells you'd find in a single microliter of blood. A microliter is so tiny you can barely see it. A single drop of blood has about 50 of them. So we are talking about 250 million cells in just one drop. It's absolutely staggering.
And every single one of those billions of cells works its tail off for about 120 days. After that, it gets retired and recycled by the body. Just think about that. It means your body is churning out millions of new red blood cells every single second in your bone marrow, all just to keep that oxygen express running on schedule. So how do they actually carry the oxygen? What's the secret? It's a special protein called hemoglobin. This is what gives blood its famous red color. The best way to picture it is like a tiny four-seater car, where each seat is perfectly designed to grab and hold on to one oxygen molecule for the ride through your body. And this whole system has to be absolutely perfect. This quote here really drives it home. A single, tiny error in that hemoglobin protein, we're talking one wrong building block out of hundreds, is what causes sickle cell anemia. That one little mistake completely warps the red blood cell into a stiff sickle shape that gets stuck in tiny blood vessels and just breaks apart. It's incredible how much depends on getting it exactly right. Okay, so if the red cells are the delivery trucks on this massive highway, what about security? What about roadside assistance? Well, that's where the defense and repair crew comes in. Their job is to protect the whole system from invaders and patch up any leaks that might happen. Now, this crew is made up of two key, highly specialized groups. First, you've got the white blood cells. They're the body's security and defense force. And then you've got the platelets, which act as the rapid response repair team. The white cells, they are the vigilant security guards of your body. I mean, they are constantly patrolling your bloodstream, your tissues, always on the lookout for threats like bacteria, viruses, and even rogue tumor cells. They are the absolute backbone of our immune system. And then you've got the platelets, and what's wild is these aren't even full cells. They're actually little fragments that get pinched off from these giant cells in the bone marrow. You can think of them as the emergency repair crew, always circulating, just waiting for the signal that there's been an injury somewhere on that circulatory highway. And the repair process is this incredible 3-step emergency protocol. It's fascinating. So first, the moment a blood vessel gets damaged, it reflexively squeezes shut to slow down the leak. Instantly, the platelets get the signal and they swarm the site, forming a temporary plug. But that's just the first patch-up job. The final step is this amazing chemical cascade that creates a tough, fibrous net called a fibrin clot, which seals the breach for good. This whole rapid sequence is called hemostasis, and it's what stops a tiny paper cut from becoming a really big problem. Okay, but there's one more crucial detail we have to talk about. Not all of these blood teams are identical. Every single person's blood has a unique ID, and getting the wrong ID during something like a blood transfusion, that isn't just a mistake, it can be a fatal one. So how is this identity determined? Well, the surface of every single one of your red blood cells is decorated with specific molecules called antigens. The easiest way to think about them is as a kind of ID badge that basically tells your body's immune system, hey, I belong here. I'm one of the good guys. And this brings us to the main blood types in what's called the ABO system. It's actually pretty simple. Your blood type is named for the antigen ID badges on your red cells. But here is the crucial part. Your body's immune system creates antibodies, the security guards, to attack the antigens you don't have. So, if you're type A, your body has anti-B antibodies, and so on. And this is what sets the stage for a potential conflict. This whole antigen and antibody system is what creates two very special categories. People with type O blood have no A or B ID badges on their cells, so no one's immune system is going to attack it. That makes them the universal donor. And then on the flip side, you have type AB people. They have both A and B antigens, so their bodies don't make antibodies against either one. They can safely receive any blood type, which makes them the universal recipient. And this is exactly why matching blood types is so critical. If you give type A blood to a person with type B blood, their anti-A antibodies will immediately go on the attack against those donated red cells. This causes the cells to clump up and burst, which is a really dangerous reaction that can lead to kidney failure and even death. Now, beyond that ABO system, there's another really important ID marker called the Rh factor. You're either Rh positive or Rh negative, and this becomes especially critical during pregnancy. If an Rh negative mother is carrying an Rh positive baby, her body can start to develop antibodies that might attack the red blood cells of a future Rh positive baby. It's a serious issue. So, to wrap it all up, it's pretty clear that blood is so much more than a simple red fluid, right? It's a dynamic, highly coordinated team. You've got the red cells handling transport, the white cells and platelets providing defense and repair, and this whole complex ID system of antigens that is absolutely vital for keeping us safe in medical situations. And that leaves us with this really fascinating idea. The blood that unites every single one of us as humans is also the very thing that makes each of us unique. So as science keeps pushing forward, what's next? Will we see artificial blood one day? Gene therapies that can fix these tiny defects before they even cause a problem? The story of this river of life is far from over. Thanks for joining this explainer.